Today we are going to cover the topics like very important topics, very interested topic. So one is we started yesterday that kinematic part of the fluid mechanics. So we are going to continue from that. So we are going to take it like what is path line, then very important what is flow rate, what is discharge. That means then what is fluid flow. Then we'll go so continuity equation. Then we are going to take up like after that. So we're going to enter into the very important practical application, that is fluid dynamics, that we're going to take up. So then what are the equations of motions, like what is the Bernoulli's equation, Bernoulli's applications like flow measuring devices, all those things we are going to take up today. So, so let me start with the first like let's start with what is path line and streamline. Okay, these are the very technical terms used in the fluid mechanics. Basically, when you are going to deal with the CFD that is computational fluid dynamics, when you are going to use the software, so they are going to analyze the flow analysis. Then they are going to streamline the word and are very important in the fluid analysis. So firstly, let me know the first path line, what it means. Path line is a trace made by a single particle over a period of time. Streamline is show the mean direction of number of particles at a same time. ಅಂದ್ರೆ ಇವಾಗ ಒಂದು ಫ್ಲೂಯಿಡ್ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ದೇರ್ ಆರ್ ಮೆನಿ ಪಾರ್ಟಿಕಲ್ಸ್ ಎಲ್ಲ ಮೂವಿಂಗ್, ರೈಟ್? ಅದ್ರಲ್ಲಿ ಒಂದು ಪಾರ್ಟಿಕಲ್ ನ ಮಾತ್ರ ಹೇಗ್ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂತ ಟ್ರೇಸ್ ಮಾಡಿದಾಗ, ಸೊ ಒಂದ್ ಪಾರ್ಟಿಕಲ್ ಏನಾಗುತ್ತೆ ಎಲ್ಲೋ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಹಿಂಗೆಲ್ಲ. ಅದು ಯಾವ ಪಾತ್ ನ ಟ್ರೇಸ್ ಮಾಡುತ್ತೆ ಅಂತ ನಾವು ಲೈನ್ ನ ಜಾಯಿನ್ ಮಾಡಿದ್ರೆ, so what is that path is show, that is called path line. But flow lines mean, so in that flow direction what are the number of particles are moving at that instant. Example, ivaga illon particle ತಗೊಂಡ್ರಾಗ, so how that flows, the particles are moving with respect to the at that instant. So one fluid is moving like this, another fluid particle moving like this, another like this. These are called as streamlines. ಸೊ ಅಂದ್ರೆ ಎಲ್ಲಾ ಪಾರ್ಟಿಕಲ್ದು ನಾವು ಪಾತ್ ನ ತಗೊಳ್ಳೋದು ಅಟ್ ಎ ಟೈಮು ಆ ಇನ್ಸ್ಟೆಂಟ್ ಅಲ್ಲಿ, ದಟ್ ಈಸ್ ಸ್ಟ್ರೀಮ್ ಲೈನ್. ಬಟ್ ಒಂದೇ ಪಾಯಿಂಟ್ ಪಾತ್ ನ ಹೇಗ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅದು ಓವರ್ ಎ ಪೀರಿಯಡ್ ಟೈಮ್ ನಾವು ಮಾಡೋದು, ಮೆಜರ್ ಮಾಡೋದು, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಪಾತ್ ಲೈನ್. ಸೊ ಬೇಸಿಕಲಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫಾಲೋ ಇನ್ ಎಂಟೈರ್ ಇಯರ್ ಸ್ಟ್ರೀಮ್ ಲೈನ್, ಬಿಕಾಸ್ ನಾಟ್ ಓನ್ಲಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಾನ್ಸಂಟ್ರೇಟ್ ಒನ್, ಸೊ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಾನ್ಸಂಟ್ರೇಟಿಂಗ್ ಆಫ್ every particle movement at that instant. Okay, at that instant, that is very important. So let's come to the now very important things called as discharge or flow measurement. So let me whenever the fluid is flowing inside a, like as example, you take this pipe, now fluid is flowing, then I need to measure how much fluid is flowing. Suppose I have a tap, so now I need to calculate out what is the amount of water is flowing now through this tap. How to measure it? So to measure that flow rate, so we have the unit called as discharge. So that we are going to use now. So what is discharge? According to the definition, it is defined as the quantity of fluid flowing per with respect to time. That means how much fluid is flowing with respect to time. That unit, quantifying that unit called as flow rate. It is also known as discharge. It is also called as discharge. So how to calculate this discharge? So this is, they are going to calculate it by area multiply its velocity. Area multiply its velocity. So that will quantity will give the rate of flow, Q. So it is unit become, area will be in meters square, suppose area, and velocity in meter per second, therefore it is become meter cube per second. So this meter cube per second is also called as Qmex. Qmex means cubic meter are nothing but meter cube per second. So in this flow rate we are going to measure in a three way. One is volume flow rate, mass flow rate, wave flow rate. So what is volume flow rate? Means in based on volume, how much volume of the water is flowing or fluid is flowing with respect to every unit of time. That quantifying volume with respect to time is measured quantity called as a volume flow rate. It is nothing but a Q only. It is nothing but Q. Q is nothing but always it measure the volume flow rate. And how to calculate this volume flow rate? So that is what? A into V will give the Q. A into V will give the Q. Next one is mass flow rate. So mass flow rate means we are not measuring the volume of the fluid. We are going to measure the how much mass of the fluid which is flowing with respect to unit time, and that is called as mass flow rate. It is denoted by letter called as m dot. So m dot is equal to rho multiply by a into v. ಅಂದ್ರೆ ಅಲ್ಲಿಗೆ ಏನ್ ರಿಲೇಷನ್ ಆಗುತ್ತೆ, we can call it as m dot equal to rho into a into v. What is called as a into v? We call it as, what is called a into v?
Discharge.
Therefore the mass flow rate and volume flow rate ಗೆ ಏನ್ ರಿಲೇಷನ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ರೋ ರೋನೆ ಅಷ್ಟೇ. ಸೊ ಅಂದ್ರೆ mass flow rate equal to rho into q. So here what is the unit become now? Mass flow rate, what is the unit become? Mass is in kg and time is in second, kg per second. So next one, wave flow rate. Andre we are not measuring the mass, not an volume also. We are going to measure the how much weight of the fluid is flowing with respect to time. That is called wave flow rate. So that is usually denoted by letter G, and that G we are going to calculate it by specific gamma. Gamma in the means specific weight of that liquid multiplied by A into V. So out of these three, which is more useful means they are going to use not weight. Either we are going to measure in volume flow rate or mass flow rate, either m dot or q. Popularly we are going to measure q, volume flow rate. Majorly we are going to follow. So we are not going to not at all we are going to measure the weight of any fluid. Okay, that's not we are going to follow. So entire in the problem of fluid mechanics also we are going to calculate the either mass flow rate, in the maximum we are going to calculate the volume flow rate. This is about that. Am I clear?
Yes, sir.
Okay. Let me ask you a question. You know, in a dams, you are seeing, you are hearing the news now, especially in the rainy season. ಎಷ್ಟು ಡ್ಯಾಮ್ ಹೊರಗಡೆ ಬರ್ತಾ ಇದೆ ನೀರು. So can anyone?
Sir, break ಆಗಿತ್ತು ವಾಯ್ಸ್ ಇಷ್ಟ ತನಕ.
ಓ ಇಸ್ ಇಟ್? ನಾನು ಕೇಳ್ತಾ ಇರೋದು ಇವಾಗ ಎಷ್ಟು ಈಗ ಔಟ್ ಬರ್ತಾ ಇದೆ ಗೇಟಿಂದ ಅಂತ, ಅದನ್ನ ಯಾವ್ದ್ರಿಂದ ಮೆಜರ್ ಮಾಡ್ತಾರೆ ಯೂನಿಟ್? Can anyone?
Qsec.
Am I audible? Qsec. Okay. Qsec. And there is a one more unit. Can anyone? Qsec. Good. There is one more unit. What is that called? TMC. Correct?
Yes, sir.
Hello?
Yes, sir.
What is Qsec means? Cubic feet. Qsec means cubic feet per second. Cubic feet per second. What is TMC means? What is TMC? 1000 million cubic feet per second. 1000 million, not 1 million, 1000 million cubic meter per second, cubic feet per second. That is called as Q6, sorry, TMC. Keep this in mind. So we are going to measure in terms of Q6. So these are the two popular unit to measure the high flow volume rate of the fluid. ಇವಾಗ ಅದು ನೀವು ಹೇಳ್ಬೇಕು ಮಾಸ್ ಫ್ಲೋ ರೇಟಾ, ವಾಲ್ಯೂಮ್ ಫ್ಲೋ ರೇಟಾ, ವೇವ್ ಫ್ಲೋ ರೇಟಾ? TMC ಅಂತ ಹೇಳಿದೆ, ಇವಾಗ Q6 ಅಂತ ಹೇಳಿದ್ರಲ್ವಾ, ಅದು ವಾಲ್ಯೂಮ್ ಫ್ಲೋ ರೇಟ್ ಯಾವುದು?
Volume flow rate.
ವಾಲ್ಯೂಮ್ ಫ್ಲೋ ರೇಟ್ ಅಂದ್ರೆ ಜನರಲಿ ವಾಟ್ ವಿ ಆರ್ ಮೆಜರಿಂಗ್ ವಾಲ್ಯೂಮ್ ಒಂದು. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಇಯರ್ ಒನ್. Okay, same thing. So let's continue the next thing. So now we are going to in the fluid dynamics, fluid mechanics, we are going to use very popular equation. So that is called as continuity equation. So what is that continuity equation? So according to the definition of continuity equation, it is based on the principle of conservation of mass. We know there are one more is there, conservation of energy. So what is conservation of energy?
Neither be created nor be destroyed.
Yes, that can be converted to one form to another. But same thing here, we are going to use conservation of mass. So conservation of mass in the sense, so how much mass is entering, let us say at section 1 in the pipe. Same thing it is, we'll get it at the section 2. So that is called, let us say section 1, the mass is M1. At section 2, let us say mass is M2. So these are two are equal. So that is called, that is, we are talking about mass flow rate. Suppose m dot 1, m dot 2. Then I can call it as m dot 1 to q. What is the relation I said? Rho. What is the relation between m dot to q? Rho q. Correct? Isn't it? Rho q1, rho q2. If density is constant, suppose in case of compressible fluid, the suppose what happened, the density will not change. Then density will become equal. Then cancel it. Then what is it become now? Q1 equal to Q2. What is Q1? We can call it as at section 1, like A1 into V1. At section 2, area of that section 2 and velocity at section 2. That is called A1 V1 equal to A2 V2. These are the very famous equation, which is going to call it as continuity equation. In case of incompressible fluid, it is A1 V1 equal to A2 V2. In case of compressible fluid, obviously what will happen? Density will changes. Then rho 1 A1 V1 equal to rho 2 A2 into V2. These are the most things we are going to use in the entire problems on the fluid mechanics. Got it?
Sir.
So in case of like, if you take the same continuity equation case of Cartesian coordinate, suppose example here, like a rectangular block. So that we there derived as dou u by dou x plus dou v by dou y plus dou y by dou y equal to 0. So this is dou u by dou x along the x direction. This is along v along the y direction and w along the z direction. So if you add it, you'll get totally 0 without any losses. So that is the thing. But it's ideal condition. Then definitely there will be a loss. So this is in case of steady flow. So if case of this is 3-dimensional. In case of 3-dimensionally, suppose in case of 2-dimension, then w will not be there. Only along x and y. Then this term will become eliminated. Then only dou u by dou x and dou v dou y equal to 0. Suppose on 1-dimensional flow, it is only dou u by dou x is equal to 0. So this is about it. So this is about, that's all about the kinematic part. Hope you clear on that. Very important thing you have to memorize the things is, as I told you, types of flow. Okay. So what is types of flows will come. Then as we discussed now, what is flow rate? All these things are very important. And one more thing I need to tell you here, Reynolds number, it's very important, laminar turbulent as I discussed. And one more thing I need to tell you here. So here we see the yesterday Reynolds number is rho Vd by mu, right? So where here rho called density of the fluid, V called velocity, D is the diameter, whereas mu is the viscosity. Now you just take an example now. I'm going to draw a Reynolds number versus mu. Mu means what? Viscosity. Now, if mu increases, what will happen to the Reynolds number? mu ಜಾಸ್ತಿ ಆದಷ್ಟು ರೆನಾಲ್ಡ್ಸ್ ನಂಬರ್ ಏನಾಗುತ್ತೆ? ಕಡಿಮೆ ಆಗುತ್ತೆ. ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. mu ಜಾಸ್ತಿ ಆದಷ್ಟು ರೆನಾಲ್ಡ್ಸ್ ನಂಬರ್ ಏನಾಗುತ್ತೆ? ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ಕರ್ವ್ ವಿಲ್ ಕಮ್ಸ್ ಲೈಕ್ ದಿಸ್. ಕರೆಕ್ಟ್. ಸೊ mu ಕಡಿಮೆ ಆದಷ್ಟು ರೆನಾಲ್ಡ್ಸ್ ನಂಬರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಏನರ್ಥ? mu ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ, mu ಜಾಸ್ತಿ ಆದಷ್ಟು ರೆನಾಲ್ಡ್ಸ್ ನಂಬರ್ ಕಡಿಮೆ ಆಗ್ತದೆ ಅಂದ್ರೆ ವಾಟ್ ಇಟ್ ಫ್ಲೋ ಬಿಕಮ್? ವೆದರ್ ಇಟ್ ಬಿಕಮ್ turbulent flow, whether it become laminar flow.
Laminar.
Yes, that means that as the more fluid become thicker and thicker, more viscous, what will happen? It will become a laminar flow. Then Reynolds number obviously is going to be reduced. So that's why. That means in case of highly viscous fluid, the laminar maximum in the case it is a laminar flow. But in case of lesser the density of the fluid, most of the cases the fluid will be turbulent in nature. That's why in oil and all you can see it is always laminar. So this is about to tell that point. Okay. So hope you clear on the kinematic part. Now we are entering to the dynamic part. As I told you, dynamic means it is also study of fluid under the motion only. Now along with that, we are going to consider the forces. Things are become bit complicated here. But this is what the practical way we need to. So therefore, when you are going to design anything, we are going to deal with on fluid dynamics part only. So maximum part on the fluid is on the dynamics. That is what I told you. Computational fluid dynamics is completely advanced. The topic is based on the fluid dynamics, because obviously whenever the fluid is flowing on the surface, there will be a forces will be acting. That we need to consider here. That is what in the entire part of fluid dynamics is here. It includes the study of the forces, what it cause on the flow. ಏನು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತದೆ, ಏನೇನು ಅದು ಹೇಗೆ ಕಾಸ್ ಮಾಡುತ್ತೆ ಫ್ಲೋ ಮೇಲೆ ಅನ್ನೋದು ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ಹಿಯರ್. And here we are going to take up mainly on the principle of Newton's second law. So that's what everywhere the Newton is law is going to apply. So here also we are going to apply that law popularly called as Newton's second law, that you know that F equal to m into a. The same thing we are going to use here also. So whenever this fluid is flowing, what are the forces will be comes into the picture. So these many forces will going to be acting whenever is any fluid. So there are 6. One is pressure force, gravity force, viscous force, turbulent flows, surface tension force, and one more is called compressibility force. So what is a pressure force? So that you know already, it is nothing. Pressure force is nothing but it is a force exerted on a fluid mass. There exists a pressure gradient between the 2 points. So that means whenever in it consider 2 points, so here P1 will be acting, here P2 will be acting, but P1 will be not equal to P2. Then there will be definitely a forces are will be different. Then there what is the corresponding force? It is called as pressure force due to the pressure. Then one more is gravity force. Obviously, anything is flow, gravity effect will be there. So this is mainly due to what? Weight of the fluid. So that weight of the fluid is equal to, we know that already popularly, that is m into g. So that is called as gravity force. Viscous force. This viscous force is mainly due to the viscosity of the fluid. So whenever the more viscous fluid, definitely this viscous force is more dominant in nature. Then next is the turbulent force. Turbulent force is due to the turbulence force due to the turbulent flow. When there is a high Reynolds number, then it is turned into a turbulent flow, then it is definitely a turbulent flow will take place. Example, when you suddenly open the wall or suddenly open the dam of the gate or waterfalls and waves, all these things. Next, surface tension force. Obviously, this is due to the mainly coercive property of the fluid mass. So the last one is compressibility force. This is due to the elastic property. Whenever you go to compress the any fluid, due to that, that compressive force going to be developed. So therefore, any fluid is flowing, these are the total forces are induced. So sum of it is pressure force plus gravitational force plus viscous force plus turbulent force plus surface tension force and everything. So using this, we have done entire fluid dynamics. We are going to deal with to study these forces. We are going to use very popular 3 equations. One is called Reynolds equation of motion, Navier-Stokes equation. Then another one is called Euler-Stokes equation of motion, popularly called as next Bernoulli equation. That you know. So what is the Reynolds equation motion? There then in the Reynolds motion, we are considering surface tension force. If the surface tension force and the compressibility force are significant and hence neglected, the net force on the fluid becomes this. So in case of the Reynolds number, they are not going to be considered the surface tension force, is not going to consider the compressibility force also, because it is not much significant. That's why he neglected that. then that equation is called Reynolds equation of motion. ಸೊ ಅದರಲ್ಲಿ ಇಷ್ಟು ಫೋರ್ಸ್ ಅಲ್ಲಿ ಇವೆರಡು ಫೋರ್ಸ್ ನ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಬೇಕು. ಯಾವುದು? ಒಂದು ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ಫೋರ್ಸ್ ಮತ್ತೆ ಲಾಸ್ಟ್ ಟು ಟರ್ಮ್ ನ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ದ ಟೋಟಲ್ ಫೋರ್ಸ್ ಬಿಕಮ್ ದಿಸ್ ಮಚ್. ಸೊ ಅದು ರೆನಾಲ್ಡ್ಸ್. ಯಾಕಂದ್ರೆ ಇವೆರಡು ಅಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಇರಲ್ಲ. ಯಾಕೆ ಅಂದ್ರೆ ಒಂದು ಅವನ್ ತಗೊಳ್ಳೋ ಕಂಪ್ರೆಸಿಬಿಲಿಟಿ ಫೋರ್ಸ್ ಎಫೆಕ್ಟ್ ಇರಲ್ಲ, ಬಿಕಾಸ್ ಮೋಸ್ಟ್ ಆಫ್ ದ ಥಿಂಗ್ಸ್ ಆರ್ ಇನ್ಕಂಪ್ರೆಸಿವ್ ಫ್ಲೂಯಿಡ್. ಮತ್ತೆ ಸರ್ಫೇಸ್ ಟೆನ್ಷನ್ ಕೂಡ ದೇ ಆರ್ ನಾಟ್ ಈಸ್ ವೆರಿ ನೆಗ್ಲಿಜಿಬಲ್. And very famous equation in the entire fluid, especially in the laminar flow comes, then the equation they are going to call it as Navier-Stokes equation. What is the first name we denoting here is the name of those scientists, those you derive that equation. So here also the Navier-Stokes is a very famous fluid scientist. So that equation is called Navier-Stokes equation. So he developed the equation of motion for laminar flow. He mainly work on the more work contribution on the viscous flow or laminar flow. So here, when there is a laminar flow, then there is no point of turbulent, which is very less significant. That's why he neglected that. Then the equation he consider what is the total force acting on the fluid is. One is gravitation, pressure, and viscous. Mainly here, viscous force is very dominant. That is called Navier-Stokes equation. So the next most popular that you are already studied called Euler. Euler also is the name of a scientist. He derived on the equation of motion. So here he not consider the viscous effect, or that means viscosity of the fluid itself he neglected. Then that equation of motion is called as Euler equation. He mainly consider pressure force and one more is gravitation force. So this is about the three equation of motion popularly we are going to use in the entire fluid mechanics. Basically, thing is when it is a turbulent flow, then the people are mainly they are going to follow with the Reynolds equation. When there is a laminar flow, then they go to use the Navier-Stokes equation. So for this is not a practical one, but this also they are going to use. They are going to use to apply the fluid flow across the different section. By considering losses, they are going to use very famous equation called as Bernoulli equations. So next thing is about the what are the different types of energy when fluid is flowing. Energy, I'm talking about energy or heat. Suppose you take a tank. So here there is a water is filled, and here there is a tap. So water is filled up to this level. Let us call it as Z. Okay. Now valve is there. So now so when I open, water is started to flow now. So now what are the energies going to develop, or what are the head is involved in that? The first most thing is potential energy. Correct. There are three important energy will be developed. One is potential energy, and then kinetic energy, then pressure energy. So potential energy means before going to open the valve, how much potential energy will be there? How much height of the water is stored, thus much energy is called as potential energy. So it is denoted by Z. Z is directly proportional to height of the water. ಎಷ್ಟು height of the water ಇರುತ್ತೋ ಅಷ್ಟು potential energy ಇರುತ್ತೆ. When I started to open this valve, all the velocity potential energy is converted into which energy?
Kinetic energy.
So then we can calculate the kinetic energy is half mv square, that you know. Here mv treated as constant, then it is become only v square by 2g. Then not only velocity, here also there is a pressure also going to be developed, right? So this potential is so that is calculated by P by small w. W means it is not weight, it is called weight density of the fluid. Keep this in mind, rho w. So that means whenever a fluid is flowing, the total eddies are sum of velocity head, pressure head, and potential head. Or in terms of energy, head is nothing but energy. In terms of energy, it is kinetic energy, potential energy, kinetic energy, and the last one is called pressure energy. If any fluid is flowing, these are the three. If three energy is induced, and if you add it or sum it off, you'll get total energy of the fluid is involved in that flowing of the fluid. So using this one, now Euler is derived his equation of motion for the fluid is flowing. So what Euler did for ideal condition that is not practically possible. So these made some assumption. So what is some assumption he made? The first most assumption is made is ideal fluid and it is incompressible. Ideal fluid means viscosity is 0. That is itself, I call it as it's a not a practical equation. Why? Because ideal fluid is never be present on the earth. That is the thing. Incompressible, it cannot be compressed like a water, and flow is steady. Yesterday I told you we discussed about types of different flows: steady flow and unsteady flow. Can anyone what is steady flow means?
Steadily, fluid characters like pressure, velocity, density do not change with time.
Yes, super good. So do not change with respect to any parameter will not change. If parameter change, then it is become unsteady flow. So he is assumed that steady flow is steady and it's also continuous. Andre water ಏನಿದೆ ಅದು continuous flow ಆಗ್ತಿರುತ್ತೆ ಅಂತ. Flow is along the streamline. I will come to that point. What is streamline? So what Euler did is he taken one what he called one cylinder type of pipe and pipe itself cylinder. Okay, he made it at an inclined line and he considered the flow is along the streamline and the streamline ಅಂದ್ರೆ ಇದೇ ಪಾತಲ್ಲಿ ಹೋಗ್ತಿದೆ ಅಂತ. So now ಅಂದ್ರೆ but practically it is not possible. ಹೆಂಗಾದ್ರೂ ಹೋಗ್ಬೋದು, but he considered the flow is only along the streamline like this. That is what he said. Velocity is uniform everywhere. Velocity is uniform, that is considered, and flow is irrotational. Yesterday also we discussed what is rotation and irrotational. Rotation means fluid is rotated at the same point. It's called rotational flow. But irrotation means it cannot be rotated. It's going to move like in a straight line path. So these are the things he considered, and also he considered only two forces. One is fluid force, that is gravity force, and pressure force. Only these two forces he considered. Then he derived the equation. Then this equation he derived, that is dp by rho plus g into dz plus v into dy equal to 0. This is called as Euler equation of motion. Euler equation of motion. So this is what the first person, that very famous Greek scientist is. He worked on the fluid flow. He derived that equation of motion for a fluid. So then there is a next one more very famous scientist. Basically, they are saying that he is from Italian. So Italian scientist, he worked on the Euler equation and he just modified the one step of this Euler equation. So he made one statement according to the equation of Bernoulli's equation statement. He is also considered the same assumption as like a Euler. In an ideal incompressible fluid, when the flow is steady and continuous, the sum of the total energy is constant. Sum of the total energy means what? What is total energy? I said
Potential energy, kinetic energy,
and
pressure energy.
Constant. Potential energy means Z, kinetic energy means V square by 2G, and pressure energy means P by rho G. All these are constant. So what he done is, same equation he followed. From the Euler equation, he just modified. How he modified? He just integrated on the both side, and finally, after integration, you know what will happen is this. So this is become P by rho, V become V square by 2G, and this is become Z. Dz becomes Z, and anyway it is constant. And dividing both by G. So anyway, this is become P by rho G, V square by 2G, G get cancelled plus Z. Anyway, constant by constant, it will cancel. Then it is only constant will be there. So this is what called as Bernoulli's very famous Bernoulli's equation. Is it clear? Is it clear? I think Madam Avagli is a very famous equation. Hope you can remember that at least. Derivation. Is it clear for all of you?
Yes, sir.
Yes, sir.
Okay. Suppose if I take the same Bernoulli's equation, considering the two sections, let us say section 1 text section 2. If you take any number of section, that is will be a constant, like section 1, section 2, section 3. We are going to replace with just suffix number. Here 1, 1, 1, here 2, 2, 2, here 3, 3, 3. That's all. It is constant. So now, but the thing is, as I told you, this is only applicable for ideal fluid. But as we know, practically there is no ideal fluid is present. Then we are all what we are using. It's called as which kind of fluid? Which kind of fluid? What we are seeing, what kind of fluid that? Ideal fluid and Allah. Ideally ಇನ್ನೊಂದು ಯಾವುದು opposite. What is that called as?
Real.
Real fluid. Real fluid means it possesses some viscosity. So then what he done is he modify his Bernoulli's equation for the real fluid. So as we know, ಇವಾಗ ಪ್ರಾಕ್ಟಿಕಲ್ ಆಗಿ ನೀವು ಇಲ್ಲಿ ಎನರ್ಜಿ ಮೆಜರ್ ಮಾಡ್ತೀರಾ ಅನ್ಕೊಳ್ಳಿ, ಲೆಟ್ ಅಸ್ ಕಾಲ್ಡ್ ಆಸ್ E1. ಬಟ್ ಇಲ್ಲಿ ಎನರ್ಜಿ ಮೆಜರ್ ಮಾಡ್ತೀರಾ ಅನ್ಕೊಳ್ಳಿ, ಲೆಟ್ ಅಸ್ ಕಾಲ್ಡ್ E2. ಬಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಅಸಂಪ್ಷನ್ ಪ್ರಕಾರ E1 ಈಕ್ವಲ್ ಟು E2 ಆಗಬೇಕು. ಬಟ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಕಂಡೀಷನ್ ಏನಾಗುತ್ತೆ? E1 ಈಕ್ವಲ್ ಟು E2 ಇರುತ್ತಾ?
ಇರಲ್ಲ.
There is never be E1 equal to E2. So why? Because there is some losses. What is that losses? There are many things, but mainly because of friction. Why friction? Due to the viscosity of the fluid. So therefore, now what we need to do? So that E1 is equal to E2 plus what is that? Loss. If we consider, then it is become real fluid. ನೀವು ಯಾವುದೇ ಫ್ಲೂಯಿಡ್ ತಗೊಳ್ಳಿ, ಫೈನಲ್ ಎನರ್ಜಿಗೆ ಅದರ್ಸ್ ಜಸ್ಟ್ ಇಫ್ ಯು ಆಡ್ ಇಟ್, if you add it losses, that will come to you will take care of other loss, everything. Then it is come to a practical condition. This is what he done. ಒಂದೇ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ದ, ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ ನ ಆಸ್ ಯೂಶುವಲ್ P1 by rho g V1 square by 2g plus Z1 ಹಾಗೆ ಇಟ್ಕೊಂಡ. ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್ಗೆ E2 P1 P2 by rho g V2 square by 2g plus Z2, ಅದರ ಜೊತೆಗೆ ಇನ್ನೊಂದು ಟರ್ಮ್ ಆಡ್ ಮಾಡೋದಂದ್ರೆ HL. So what is HL means head loss. That loss is, if you take it, that is the difference of E1 and E2. E1 and E2 difference ತಗೊಂಡ್ರೆ you will get what is the loss, isn't it?
Yes sir.
Okay. So just one modification ಅಲ್ಲಿ ಎಲ್ಲ ಆಗ್ಬಿಡ್ತು. ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇತ್ತಂದ್ರೆ ಈ ಜಸ್ಟ್ ಸಾಲ್ವ್. ಓಕೆ ಆಯ್ತಪ್ಪ, ಲಾಸ್ ಆಡ್ ಮಾಡು ಬಂದ್ಬಿಡ್ತಂತೆ. ಸೊ ಅಲ್ಲಿಗೆ now that's why we are going to use now till today. So let's enter into the now practical. What is this practical application of this Bernoulli's equation? So mainly this Bernoulli's equation we are going to use for the all types of incompressible fluid, and especially to measuring devices to measure the flow rate, like Venturi meter, orifice meter, elbow meter, pitot tube we are going to use. So now let me see now flow measuring devices. We know here there are measuring devices used for to measure the flow rate in a closed conduit. Closed conduit in the sense pipe is called closed conduit, and some measuring devices is used for open conduit. Open conduit in the sense channel,
Dam.
all those things will come. So for closed conduit, these many popular the measuring devices are going to use Venturi meter, orifice meter, rotometer or pitot tube. For open conduit, either notches where they are going to use. Let me see one by one now. First, Venturi meter. I think Venturi meter, you can recall this name, right? Figure ella barditira. So it's an important question in the exam. So Venturi meter is a device used to measure the flow rate of fluid. Which flow rate means, again it is a volume flow rate only. Okay, Venturi is the name of a scientist. So he is a famous Italian engineer. It's called Venturi. He invented this type of meter that is called Venturi meter. So he has applied the Bernoulli's equation to derive this flow rate equation for the Venturi meter. So in the Venturi meter there are three types basically: horizontal, vertical and inclined. Based on the position of the pipe, they are derived. Suppose horizontal pipe ge fix ಮಾಡಿದ್ರೆ ಅದು horizontal Venturi meter, vertical pipe ge vertical Venturi meter, inclined banda inclined Venturi meter. So most popularly we are going to use horizontal Venturi meter. So that is it mainly consisting of three parts. Can anyone recall that name? What is the three parts?
Throat.
Yes. First one, throat ginta munche enidu? It will be like convergent, right? This is called convergent section. So this is called convergent section, and after the convergent section, there will be a constant area will be there. This is called a throat, and after that again area will be increased. This is called divergent. Basically, it consists of these three parts: convergent, divergent, and throat. So now here in between, so what the main working principle of this will be, so when area reduces, like in a convergent section, pressure what happens? Pressure ಏನಾಗುತ್ತೆ? ಕಡಿಮೆ ಆಗುತ್ತೆ. ವೆಲಾಸಿಟಿ ಏನಾಗುತ್ತೆ? ವೆಲಾಸಿಟಿ ಏನಾಗುತ್ತೆ? ಪ್ರೆಷರ್ ಕಡಿಮೆ ಆದಾಗ ವೆಲಾಸಿಟಿ ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗುತ್ತೆ. That is the principle used here. That's all. So when area decreases, illi pressure decreases, and all the pressure energy is converted into a kinetic energy, and that kinetic energy, with the difference of kinetic energy with respect to throat to the pipe area, that can be the pressure difference. They can be measured by connecting the manometer, either that is popularly U-tube manometer. This amount of X will give the amount of how much difference in the at section 1 to 2. So now based on this, I applied the what is that Bernoulli's equation at section 1 at the pipe and section 2 at the throat. Then he derived the equation, and that equation is called as, that is Q equal to A1 A2 by root of A1 square minus A2 square into 2 times of 2GH, where A1 is the area at pipe section, that is section 1, and A2 is the area at the throat, whereas H is the pressure rate between the section 1 to section 2. By using a manometer, what is the value you get, that you need to plug into it. So this will measure the discharge value. But so this is basically a theoretical one. ಸೊ ಇಲ್ಲಿ ಮಾಡಿದಾಗ ಒಂದು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ, ಬಟ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಮಾಡಿದಾಗ ಅದೇ ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಇರುತ್ತಾ? ಇಲ್ಲಿ ಮೆಷರ್ ಮಾಡಿದಾಗ ಅಷ್ಟೇ ಸೇಮ್ ಇರುತ್ತಾ? ಹಲೋ, no, there will be no. That is called actual. So why this difference will be? Because there again there is a so many. Here also he is not considered any losses. Okay, so and also here there is a chances of backflow, there is a chances of turbulent flow, and also there is a chances of a vortex flow, that is rotational flow. So therefore there will be always difference in the reading compared to the theoretical reading. Always the theoretical discharge will be greater than the actual discharge. So therefore, then how to compensate this value? In order to compensate, so we are going to use this one of the term called as CD. What is CD means? What is CD? Quotient of discharge. So what is quotient of discharge means? It is a ratio of theoretical discharge to the actual discharge. So therefore, what is actual discharge become CD times of theoretical discharge. So what is CD theoretical discharge means? You just plug in this equation here, then this will give the what is the actual amount of the discharge. So this CD value theoretically and the not theoretically and the practical experimental way, that value will be around 0.98. I will ask you one question here. Hello, break ಆಗ್ತಿದ್ಯಾ? 1 minute. It is visible. Now I will ask you one question. Tell me, I told you CD is nothing but it is a ratio of theoretical discharge to the actual discharge. Now tell me, what is the maximum value of the CD? Maximum value ಎಷ್ಟು ಬರಬಹುದು CD? What will be the maximum value of CD?
1.
Good. How it is 1?
ಥಿಯರಿಟಿಕಲ್ ಮತ್ತೆ ಆಕ್ಚುಯಲ್ ಎರಡು ಸೇಮ್ ಇದ್ರೆ 1 ಆಗುತ್ತೆ.
Yes, super. So actually ಯಾವತ್ತು never be more than the theoretical ಅಲ್ವಾ? Yes or no? As is
Yes,
said.
sir.
So ಏನ್ ಇನ್ ಐಡಿಯಲ್ ಕಂಡೀಷನ್ ತಗೊಂಡ್ರು ಕ್ಯೂ ಆಕ್ಚುಯಲ್ ಕ್ಯೂ ಥಿಯರಿಟಿಕಲ್ ಈಕ್ವಲ್ ಆಗ್ಬೇಕು. ಅವಾಗ ಇವೆರಡು ಈಕ್ವಲ್ ಆದ್ರೆ ಯಾವಾಗ ಇವೆರಡು ಈಕ್ವಲ್ ಆಗುತ್ತೆ? ಇದು ಇವೆರಡು ಈಕ್ವಲ್ ಆದ್ರೆ ಎರಡೆರಡು ಕ್ಯಾನ್ಸಲ್ ಆದ್ರೆ ಏನಾಗುತ್ತೆ? 1 ಅಂತಾನೆ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಇಸ್ ದ ಥಿಂಗ್. ಬಟ್ ಪ್ರಾಕ್ಟಿಕಲಿ ಇಟ್ ಇಸ್ ನೆವರ್ ಬಿ 1, ಇಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಲೆಸ್ ದೆನ್ 1. ಇದಕ್ಕೆ ಕೇಳ್ತಾರೆ ಕ್ವಶನ್, ಸಿ ಡಿ ವ್ಯಾಲ್ಯೂ ಯಾಕೆ ನೆವರ್ ಬಿ ಮೋರ್ ದೆನ್ 1 ಅಂತ. ಓಕೆ, ಸೊ ದೆನ್ ದ ನೆಕ್ಸ್ಟ್ ಒನ್, ದಿಸ್ ಇಸ್ ಅ ವೆರಿ ಫೇಮಸ್ ಮೀಟರ್ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್. ನೌ ಯು ಕ್ಯಾನ್ ಸಿ ಇದ್ರ ನಾನು ಹೇಳಿದ್ದೆ ಸಿ ಡಿ ವ್ಯಾಲ್ಯೂ ಫಾರ್ ದ ವೆಂಚುರಿ ಮೀಟರ್ ಎಷ್ಟು ಅಂತ ಹೇಳಿದೆ ನಾನು. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ವ್ಯಾಲ್ಯೂ ಅರೌಂಡ್ 0.98. ಅಂದ್ರೆ 1ಗೆ ಎಷ್ಟು ಕ್ಲೋಸ್ ಆಗುತ್ತೋ ಅಷ್ಟು. ಅದ್ರ ಮೀನಿಂಗ್ ಏನು? ವ್ಯಾಲ್ಯೂ 1 ಕ್ಲೋಸ್ ಬರ್ತಾ ಇದ್ದಷ್ಟು ಮೀನಿಂಗ್ ಏನು ಅಂದ್ರೆ ಆಕ್ಚುಯಲ್ ಆಲ್ಮೋಸ್ಟ್ ಈಕ್ವಲ್ ಟು ದ ನಿಯರ್ ಟು ದ ಥಿಯರಿಟಿಕಲ್. ಅಂದ್ರೆ ಈಗ ನೋಡಿ 0.98 ಅಂದ್ರೆ ದಿಸ್ ವಿಲ್ ಗಿವ್ ದ ಮೋಸ್ಟ್ ಆಕ್ಯುರೇಟ್. But let me see in the next case, RFIs. So RFIs meter means is also used for the to measure the flow rate in a pipe, but here they are going to use just circular plate. They made a hole at the center. This called as RFIs area, RFIs dia or RFIs area. So here also they are going to fix in between the pipe, and they are going to here also they are going to use the same principle. By reducing the pressure, all the pressure energy is converted into a kinetic energy. That increase in the kinetic energy is used to measure the flow rate here. So here they fix it, let us call it here section 1, and after just the plate they are considered section 2. Now across these two there is a pressure difference. In order to measure the pressure difference, they fixed one manometer here. Now they are derive the equation. It is same as the same thing previous one only. So only thing is here A1 stands for diameter of the pipe. A naught stands for diameter of the what you called RFIs, area of the RFIs. So here CD value around 0.65. 0.65 ಅಂದ್ರೆ ಯಾವ್ದು? ಈಗ 0.65 ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಸೊ ಇಟ್ ಈಸ್ ಇನ್ಯಾಕ್ಯುರೇಟ್ ಕಂಪೇರ್ಡ್ ಟು ದ ವೆಂಚುರಿ. ಅಂದ್ರೆ ಲಾಸಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಯಾಕಂದ್ರೆ ಸಡನ್ ಆಗಿ ಫ್ಲೋ ಆಗೋದು ಇಷ್ಟೇ ಏರಿಯಾದಲ್ಲಿ ಹೋಗ್ಬೇಕಲ್ಲ, ಅವಾಗ ಏನಾಗುತ್ತೆ? ಟರ್ಬುಲೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ, ವರ್ಟೆಕ್ಸ್ ಫ್ಲೋ ಕೂಡ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಜೊತೆಗೆ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿಂದ ಕಾಂಟ್ರಾಕ್ಟ್ ಆಗಿ ಇನ್ನೂ ಏನಾಗುತ್ತೆ, ಫರ್ದರ್ ಫ್ಲೂಯಿಡ್ ಫ್ಲೋ ಆಗಿ ಇಲ್ಲಿ ಆಕ್ಚುಲಿ ಏರಿಯಾ ಮಿನಿಮಮ್ ಬರುತ್ತೆ. ಇದನ್ನ ಏನೋ ಏರಿಯಾ ಅಂತ ಕರೀತಾರೆ ಅಂದ್ರೆ ವೀನಾ ಕಾಂಟ್ರಾಕ್ಟ ಏರಿಯಾ. ನಮ್ ಪ್ರಕಾರ ಇಲ್ಲಿ ವೆಲಾಸಿಟಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರಬೇಕು. ಎಲ್ಲಿ RFIs ಏರಿಯಾ ಇದೆಯೋ ಅಲ್ಲಿ ಮಿನಿಮಮ್ ಬರಬೇಕು. ಬಟ್ ಏನಾಗುತ್ತೆ, ಪ್ರಾಕ್ಟಿಕಲ್ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಇದ್ರೊಳಗಡೆ ವಾಟರ್ ಫ್ಲೂಯಿಡ್ ಹೋದ್ಮೇಲೆ ಫರ್ದರ್ ಸ್ವಲ್ಪ ಮುಂದೆ ಪ್ರೊಸೀಡ್ ಆಗಿ ಇನ್ನೂ ಏರಿಯಾ ಏನಾಗುತ್ತೆ, ಕಡಿಮೆ ಆಗುತ್ತೆ, ಕಾಂಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ. ಏರಿಯಾ ಕಾಂಟ್ರಾಕ್ಟ್ ಆದಷ್ಟು ವೆಲಾಸಿಟಿ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಬಟ್ ನಾವು ತಗೊಳ್ಳೋ ಏರಿಯಾ ಯಾವುದು ಅಂದ್ರೆ ವೀನಾ ಕಾಂಟ್ರಾಕ್ಟ್ ಏರಿಯಾ ಅಲ್ಲ, RFIs ಏರಿಯಾ. ಅದರಿಂದ ಅದು ಆಕ್ಯುರೇಟ್ ಇರಲ್ಲ. ದಟ್ ಈಸ್ ದ ಮೇನ್ ರೀಸನ್ why CD will be low for this. Am I clear?
Yes, sir.
Hello? Others? How many are there? I don't know. All of you understood?
Yes, sir.
Okay, next one is also very famous one, rotameter. So rotameter will give the directly the discharge value. You no need to measure, plug in this value here. ಇಲ್ಲೇನ್ ಮಾಡ್ಬೇಕು, ನಾವು ಮೆಜರ್ ಮಾಡಿ ಈ ಈಕ್ವೇಶನ್ ಗೆ ಪ್ಲಗ್ ಮಾಡಿ ವ್ಯಾಲ್ಯೂಸ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಬಟ್ ಇಯರ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಲೈಕ್ ದಟ್. ಸೊ ಇಯರ್ ಓನ್ಲಿ ಡೈರೆಕ್ಟ್ಲಿ ದೇ ವಿಲ್ measure the directly the marking what you are seeing itself, it is discharge value. So here in the rotameter there is a called as floater. So floater usually will be lighter one, and so whenever the fluid is entering here, so because of this pressure force it going to be rises. So how much height it will gives rise, based on that directly you can measure the how much that discharge value. Or you can use this equation also to measure the theoretical discharge of this. Okay, so this is called rotameter. Then very famous one more is called pitot tube. So most of the in aerodynamics, like aerospace field, aerodynamics field, they are going to use this one. Basically, pitot tube will never be measure the direct discharge. Actually, it will measure the what? Hello?
ಪ್ರೆಸೆಂಟೇಶನ್ ಸ್ಟಾಪ್ ಆಗಿದೆ ಸರ್.
ಬರ್ತಾ ಇದೆ.
ಅಂದ್ರೆ ನಿಮ್ದು ಡೇಟಾ ಬೇರೆಯವರಿಗೆಲ್ಲ ಬರ್ತಾ ಇದೆಯಾ?
ಎಸ್ ಸರ್.
ಅದರ್ಸ್? ಓಕೆ, ಮೇ ಬಿ ನಿಮ್ದು ಡೇಟಾ ಇದಾಗಿರ್ಬೇಕು ನೋಡಿ, ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಆಗಿರ್ಬೇಕು. ಸಿ, ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ, pitot tube will never measure the discharge. Actually, it is used for measure the what? Velocity. It is used to measure the, it is one of the most accurate devices used to measure the velocity. That's why this is going to be used to measure the velocity. Suppose flight ಎಷ್ಟು ಫ್ಲೋ ಇದಾಗಬೇಕಾದ್ರೆ ಎಷ್ಟು ವೆಲಾಸಿಟಿ ಏರ್ ಅಂತ ಮೆಜರ್ ಮಾಡಕ್ಕೆ ಫ್ಲೈಟ್ ಅಲ್ಲೆಲ್ಲ ಫಿಕ್ಸ್ ಮಾಡಿರ್ತಾರೆ ಇದನ್ನ. ಯು ಕ್ಯಾನ್ ಸಿ ಇನ್ ದ ಇಮೇಜ್ ಹಿಯರ್. ಇನ್ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ flight movement, the air will be enter here, and that will give the what is the amount of air velocity. Another. So same thing in the rocket, everything they are going to use this. So is one of the accurate device for velocity measurement. It works on the principle of that if the velocity flow at a point becomes zero, then the pressure there is a increase due to conversion of kinetic energy. See, ಇಲ್ಲೇನಾಗುತ್ತೆ ಉಲ್ಟಾ. ಇಷ್ಟು ಕೇಸಲ್ಲಿ ಏನಾಗ್ತಿತ್ತು, ವೆಂಚುರಿ ಮೀಟರ್ ಅಲ್ಲಿ ಮತ್ತೆ ಇದ್ರಲ್ಲೆಲ್ಲ ಪ್ರೆಷರ್ ಎನರ್ಜಿ ಡಿಕ್ರೀಸ್ ಆಗಿ ಕನೆಟಿಕ್ ಎನರ್ಜಿ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇತ್ತು. ಬಟ್ ಇಲ್ಲೇನಾಗುತ್ತೆ ಅಂದ್ರೆ, ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಇಯರ್ ದೇರ್ ಇಸ್ ಎ ಪೈಪ್. ಸೊ ಇಯರ್ ದೇ ಆರ್ ಫಿಕ್ಸ್ಡ್ ಎ pitot tube. Pitot tube usually like a 90-degree pipe, small pipe. Here, what will happen when the fluid is flowing? This pitot tube always used to place in opposite direction of flow. ಯಾವ ಕಡೆ ಫ್ಲೋ ಬರ್ತಾ ಇರುತ್ತೆ ಅದು ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಬೇಕು. ಸೊ ಇಲ್ಲೇನಾಗುತ್ತೆ, ಹಿಂಗ್ ವಾಟರ್ ಫ್ಲೂಯಿಡ್ ಹಿಂಗ್ ಬಂದಾಗ, ಸೊ ದಿಸ್ ಪಾಯಿಂಟ್ ವಾಟ್ ಯು ಕ್ಯಾನ್ ಸಿ ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಸ್ಟಾಗ್ನೇಷನ್ ಪಾಯಿಂಟ್. So that stagnation point means what means? So where all the velocity of the fluid becomes zero, and because of the fluid velocity becomes zero, all that this kinetic energy is converted into a pressure energy. Because of the convert into a pressure energy, it is going to be rise in the tube. And how much tube it will rise, that can be measured, that height of level of the fluid, that will give the velocity value. How means? Using this equation, that is V is equal to root of 2gh. So 2g delta h. Okay, what is delta h means is here, one is stagnation head and another one is called h naught. It is called static head. Stagnation head and static head. Keep this in mind. These all terms are in the aerodynamic field. It's very important. Stagnation point andre enu andre velocity zero agodu. Okay, so stagnation head andre ee stagnation point in the pitot tube alli ಎಷ್ಟು height water rise ಆಗಿರುತ್ತಲ್ಲ fluid, that if you measure, that is called stagnation head. And what is static head means? We are going to fix one piezometer on the surface of the pipe. So here what is the amount of height it will be rise in the fluid, no, due to the pressure energy, that is called static head. If it takes the difference of these two, will give the delta h value. So then they will going to measure the velocity. So this is the working principle of this pitot tube. Matte how you can ask me question, then sir ನೀವು ಹೇಳಿದ್ದು flow measurement ಅಂತ, how it is measuring? It is measuring velocity. Then how you can measure the flow rate or Q? Can anyone? Q ಹೆಂಗ್ measure ಮಾಡುತ್ತೆ ಇದು? V ಮಾತ್ರ measure ಮಾಡೋದು ಇದಾಗದ್ರೆ, ಮತ್ತೆ Q ಹೆಂಗ್ measure ಮಾಡುತ್ತೆ? Can anyone answer for this? We know what is Q? General equation A into V. V ಗೊತ್ತಾದ್ರೆ A Q ನ we can able to calculate. That is the way. ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲ್ಲ, ಇಂಡೈರೆಕ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. ಬಟ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಿದ್ದು ವೆಲಾಸಿಟಿ. Am I clear?
Yes, sir.
Okay. So now let's come to the last part of this flow measuring devices, that is notch and weigh. So notch is basically used to measure the flow rate in a like channel. ಈಗ ಚಾನಲ್ ಎಲ್ಲ ಎಷ್ಟು ಹೋಗ್ತಾ ಇದೆ ಅಂತ ಹೇಗೆ ಮೆಷರ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ like these plates. Basically these plates are made up of metals. Okay, there are different types of notches shapes will be there. Either it may be like V shape, rectangular shape, trapezoidal shape, or stepped shape like this. Okay, so this is used to measure the flow rate across the what across the notches, sorry, channel. And where is used to measure the flow rate across the dam. It is usually made up of concrete. You can see here ಈ ತರ ಎಲ್ಲ ಸ್ಲೋಪ್ ಮಾಡಿರ್ತಾರಲ್ವಾ, ಅದೆಲ್ಲ ಏನು ಅಂತಂದ್ರೆ ವೇರ್ ಅಂತ. ಸೊ ಹೇಗ್ ಮೆಜರ್ ಮಾಡ್ತಾರೆ ಇದನ್ನ ಅಂತಂದ್ರೆ, ಇಲ್ಲೇ ಒಂದು ಸ್ಕೇಲ್ ಇಟ್ಟಿರ್ತಾರೆ. ಇಲ್ಲಿ ನೀವೆಲ್ಲಾದ್ರೂ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಇಲ್ಲೆಲ್ಲ ಸ್ಕೇಲ್ ಇಟ್ಟಿರ್ತಾರೆ, ಒಂದು ಲೀನಿಯರ್ ಸ್ಕೇಲ್ ಸೇಮ್ ನಮ್ಮ ಹತ್ರ ಇರುತ್ತಲ್ಲ ರೂಲರ್ ತರ. ಸೊ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಹೈಟ್ ಆಫ್ ವಾಟರ್ ಎಷ್ಟಿದೆ ಅಂತ ರೆಕಾರ್ಡ್ ಆಗುತ್ತೆ. ಆ ಹೈಟ್ ಆಫ್ ವಾಟರ್ ರೆಕಾರ್ಡ್ ಆದಾಗ ಆ ವ್ಯಾಲ್ಯೂ ತಗೊಂಡು ದೇ ವಿಲ್ ಪ್ಲಗ್ ಇನ್ ಟು ದಿಸ್ ವ್ಯಾಲ್ಯೂಸ್. ಸಪೋಸ್ ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ನಾಚ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರೆ ಈ ಎಚ್ ವ್ಯಾಲ್ಯೂ ಅದರೊಳಗಡೆ ಪ್ಲಗ್ ಇನ್ ಮಾಡಿದ್ರೆ ಯುಲ್ ಗೆಟ್ ವಾಟ್ ಇಸ್ ದ ಡಿಸ್ಚಾರ್ಜ್. ಅದೇ ತರ ಟ್ರಯಾಂಗ್ಯುಲರ್ ನಾಚ್ಗೆ ದಿಸ್ ದ ಈಕ್ವೇಶನ್, ಟ್ರಾಪೆಜಾಯ್ಡಲ್ ನಾಚ್ಗೆ ದಿಸ್ ದ ಈಕ್ವೇಶನ್. ದೇರ್ ಆರ್ ಮೆನಿ ಟೈಪ್ಸ್ ಆಫ್ ನಾಚಸ್ ವಿಲ್ ಬಿ ದೇರ್. ಅದೇ ತರ ವೇರ್ ಕೂಡ ದೇರ್ ಆರ್ ಮೆನಿ ಟೈಪ್ಸ್ ವಿಲ್ ಬಿ ದೇರ್. And these are the equation for different types of discharge equation for wear. If you know, you can see here only H is varying. So if you know the H, you can able to calculate the Q. So that is the way they are going to do this. Calculator ಮಾಡೋದು ಈ ತರ. ಗೊತ್ತಾಯ್ತಾ? Hello?
Yes, sir.
Okay, what is the time?
10:30.
Okay, will we stop it here or we need to continue? ಏನ್ ಮಾಡೋಣ?